Okay, in this lecture, we'll calculate the rotations and deflections in space frames using flexibility method. In 2D structures, frames or beams, we can use Cauchy-Leno's theorems, method of consistent deformations to calculate deflections and rotations. However, in case of space frames or 3D frames or 3D structures, it is quite difficult to apply those methods and to calculate rotations and deflections. So flexibility method is a useful tool in this regard. Okay, we have a space frame. It's a frame, and it's a determinate frame. And you know that the SI of a frame is equal to 6m plus r minus 6j, and we have 6 parameters per member. It should be known that these parameters are shear in Vx, y direction, in z direction, moment in x, moment in y, and moment in z. Similarly, we have 6 equations per joint, and same equations. I mean, sigma fx, sigma fy, sigma fz, because it's a space frame, and then sigma fx, sigma my, and sigma mc, all 0. Anyways, it's a determinate frame, so you have to calculate the rotation. You have to calculate the translations and rotations in all these 6 parameters. Now this is translation in x direction, this is in y, and this is translation in z. This is rotation in x, this is rotation in y, and this is rotation in z. Actually, I have to show my frame of reference. The coordinate system should be shown here. This is y, and this is my x, and this is my z. So if I am referring to delta x, it means I am calculating the translation in this direction. This vertical is y, and this towards you is z. So it's easy. Some data is also given. This is E is equal to 32,000 ksi, and then I is, moment of inertia. G is torsional rigidity, and J is actually polar moment of inertia. You should know that in this formula, dx divided by EI, this is a flexural rigidity. However, if you have to use the torsion, you have to multiply the torsions, then you have to use this formula Gj. Now this is the torsional rigidity, and this is the modulus of rigidity. So that's why, because we are going to construct the moment tables, so there would be some torsions there. So that's why we have to use this formula. It may be, it may be used. So I'm going to calculate few of these parameters, not all. So I'll calculate. I have to calculate del z. Okay, I'll calculate del z, translation in z direction at point E, and second one is rotation in x direction at point T. You should know that in any point in space frame, I have the following possibilities. For example, there can be a translation in y direction, there can be translation in x direction, there can be a translation in z direction. Similarly, there can be a rotation in x direction, there can be rotation in y direction, and there can be a rotation in z direction, because it's a space frame. So that's why these 6 parameters are to be calculated. So what I'll do, that I'll apply a unit action in all these cases. First of all, before I continuing the before I calculate all these parameters, I have to do this step. I have to calculate the free body diagram of this frame under applied loading. So I have to construct this moment table. This is a moment table I have constructed. So now I'm going to show you that how I have constructed this. Okay, you have a vertical load at E and you have a UDL in Y direction on member BC, and this is member AB, 15 feet, this is 10 feet. It's very easy. This is a basic, determinate. This is already a determinate structure, so I can easily calculate the free body diagrams. Okay, starting with the free end, I have a 10 kip load in Y direction, and this I have to balance this. So I'll balance it with a vertical 10 kip. Okay, you should know that this is in Y direction and this member is in X direction. So there would be a moment in Z. Now you should know the combination is that the load is in Y, the member is in X, and moment should be in Z. So 10 into 8, it forms, if you rotate it towards point D, it forms a clockwise moment. So I have to apply an anti-clock resistive moment. So I have applied 80 kip foot. This is anti-clockwise. So you should know that these are my notations. This is actually a moment in Y, and this is moment in Z, and this is my moment in X, and they are all counterclockwise. This is, by the right user, by using right hand rule, and that has been explained earlier, but okay, these all moments are clockwise. This is in Y, this is in X, and this is in Z direction, and these are clockwise. Okay, this is forming a clockwise, so I have applied an anti-clockwise moment, counterclockwise. You can see here this member has been balanced. Next I have to balance this joint D. This 10 kip is upwards, so I have to balance it with downwards 10 kip. Okay, this 80 kip is in counterclockwise, so I have applied equal and opposite in clockwise direction. Next, this 10 kip is balanced here, and you know this is clockwise, so I have balanced it with anti-clockwise 80 kip foot. Again, I have to balance this joint C. This joint C should be balanced, so I have balanced it here. This is upward 10 kip, so I have applied a downward 10 kip, and this is anti-clockwise 80 kip foot, so I have applied a 80 kip foot clockwise. You should know that this is a clockwise moment here. Okay, let me use a pen with another color. Okay, again I have applied load of 2 kip foot, and 2 into 20 gives us 40. Downward is 40, and this is 10. 40 plus 10 gives us 50. So I have to balance it with 50 kip foot. And again, this is 80 kip foot, and you know that this is in Z direction. This member is also in Z direction. So this is actually a torsion. So this would be balanced here. That would be balanced here, 80 kip, 800 kip foot. That is easily transferred as it is. And finally, I've calculated this 600 kip foot. This is very easy. Using the laws of mechanics, I can easily calculate it. For example, for example, this, this is in Y, this is in Y, and this is member is in Z direction. So it means a moment would be in X. So it is forming a clockwise movement. So 10 into 20. Okay, from upwards, this is Y, this member is in Z direction, so there would be a moment in X direction. So that moment, the magnitude of that moment would be equal to 2 into 20 into 10. Because if you solve it, you will get 600 kip foot. So I have applied it. Again, I'll balance this member B, joint B. 50 kip is upward, so I'll apply a downward 50 kip. This 600 kip foot would be balanced with 600 kip foot, because this is in counterclockwise, so I have to apply it in clockwise direction. Okay, this 800 kip foot is in obviously this is a counterclockwise, so I have balanced it with a clockwise direction. Okay, this is actually 80. You should know that this is 80. This is not 800. This is 80. This is a mistake, but this is 80. Okay, this is also 80. Okay, next, this 50 kip has been balanced with 50 kip. this 80 kip foot is clockwise, so I have applied anti-clockwise, counterclockwise 80 kip foot. This 600 kip foot is in clockwise direction, so I have balanced it with anti-clockwise. Next, I have constructed a moment table, and it's very easy. And for example, for member DE, my origin is E, so, and this distance would be Z. Now this 10 is in Y and this member is in Z, and if you rotate it towards this point, so it forms a moment that would be 10Z. And this is X, this is X, this is 10X. So it is Y and this is in X, so the moment would be under MC. So 10 into X, it is forming a clockwise moment, so I have to apply a resistive. So that's why I have written a minus 10X. Next, in member DC, my origin is D and this is Y, and I have to find all moments here. So this is a pure moment, and you should know that this is a clockwise moment, so I have to balance it with anti-clockwise moment 80 kip foot. So this is minus 80. Counterclockwise is negative here. Okay, finally this member, and member origin is B. In member BC, my origin is C. Okay, this is my pen. So I have to find all moments here. You should know that this 10 kip would form a clockwise moment, and you should know this distance is Z. Y, this load is Y, is in Y. This member is in Z, so moment would be in MX. The combination is Y, the member is in Z, so moment would be in X. Okay, this 10 kip is forming a moment, 10Z. It's forming a clockwise, so the resistive would be minus 10Z. So I have applied a minus 10Z. Okay, from upwards I have a load that is 2 kip foot and 2 into Z, because it is acting up to section Z, up to this length 2Z, and the moment would be Z by 2 Z square. It is forming a clockwise moment because it is acting downwards, so it is forming a clockwise moment. So this would be resistive as well. That's why it's a minus here. Okay, this 80 kip foot, let me remove all this. This 80 kip foot is in clockwise direction, so it can be easily transferred here. Minus 80, because this is resistive. And you should know that this member is in Z and this moment is also in Z, so this is a torsion. So that's why it is under TZ. Okay, finally, I have a member AB and my origin is B, and I'll do, this is my section, this is Y, and I have to find all moments here. Okay, the 600 kip foot is a pure moment, and this is clockwise, so the resistive would be anti-clockwise in Z, 600. This is minus, and this is also counterclockwise. Okay, this 80 kip foot is actually clockwise, so the resistive would be minus 80. So that's why it's a minus here. Done. Okay, next I have to calculate the del Z. You know, this is, I have to calculate a translation in this direction, del Z, at point E. So for that I have to apply a unit redundant action, and that should be a load. If I have to calculate theta at Z at point E, so I'll apply a unit moment. But as I have to calculate the translation, and translation is always related with the load, and theta Z is, or rotation is always related with moment. So I have to find the del Z. That's why I have to apply a load in Z direction. Okay, I have applied a load, and again I have to, because it's a determinate frame, so you have to calculate, you have to draw the free body diagrams. So this one cap is balanced with one cap, and you should know that this is forming a clockwise moment here. You should know this is Z and this is X. The combination is weird. ZX, the combination should be Y. Moment should be in Y. This is forming a clockwise, so I have to apply resistive anti-clockwise. You should know that these are all my anti-clockwise in 3 directions. These are my counterclockwise moments. Okay, clockwise, so I have applied with anti-clockwise. Okay, again I have to balance this joint. This is counterclockwise, this is clockwise. Okay, one cap equal and opposite one cap. Again, this 8 cap foot would be balanced with 8 cap foot because it's a torsion, so it's a pure torsion. It would be transferred as it is. This one cap with one cap. Again, this one cap is in Z direction, and this member is in Y direction. So there would be a moment in X direction. Okay, this one cap is forming a moment that is clockwise. 1 into 10. Resistive would be counterclockwise, minus 10. Okay, balancing this joint C, 8 cap foot would be balanced with 8 cap foot. Upward, downward means counterclockwise, clockwise. 10 cap foot counterclockwise, balanced with clockwise. 1 cap with 1 cap. Next, no loading here. Okay, this member has to be balanced in terms of moments, in terms of loads. 8 cap foot and upward 8 cap foot. 10 cap foot is in clockwise, so I have applied a counterclockwise here. This is 1 cap, this is 1 cap. Again, I have to balance this joint B. So 1 cap is balanced with 1 cap. 8 cap foot upward is balanced with 8 downwards, 8 cap foot. This 10 cap foot rightwards has been balanced with 10 cap foot leftwards. Finally, this one, again I have to balance this member. 1 cap foot would be balanced with 1 cap foot. This downward 8 cap foot would be balanced with 8 cap foot. 10 cap foot would be balanced with 10 cap foot. So I am done. You have to do little practice to learn this. Finally, I have to construct this moment table. Origins would be same as in the previous case. Okay, DE, my origin is E. You should know that this is X and this is Z. So Z, X and moment would be in Y. This is forming a clockwise. If you rotate it towards this point, it's a clockwise. Resistive would be minus X, and that would be in Y. Okay, in this case, in this member, our origin is D. This is Y. I'm sorry. Okay, 8 cap foot here. Okay, I have to find all moments here. So you should know that this 8 cap foot is clockwise. This is clockwise and it's a torsion. So it can be balanced here with upward torsion, and that would be counterclockwise. For the member, this member, CD. So I have applied this. Member BC, no, member C. This is a torsion I have applied, minus 8. Not this, this, minus 8. Okay, this 1 cap foot is forming a clockwise moment here. 1 cap foot is in Z direction. This is in Y. So it would form a moment in X direction. It's forming a clockwise. Resistive would be anti-clockwise. The magnitude would be Y, 1 into Y. That's why I have a minus Y, a moment in the X direction. Okay. Next, the member BC and the origin is C. Origin is C, yes. And this is obviously this is Z. I have to find all moments here. This 10 kip foot would be balanced with 10 kip foot. This is clockwise, so I'll apply a counterclockwise 10 kip foot. Okay, this 8 kip foot is moment in Y direction. It would be balanced with upward 8 kip foot. That would be a counterclockwise. Finally, member BA, and the origin is B, and you should know that I have to find all moments here. This 8 kip foot is torsion in downward, so I have to balance it upward, and you should know that this is counterclockwise, it should be -8, torsion in Y direction. This 10 kip foot would be balanced. This 10 kip foot would be balanced with equal and opposite 10 kip foot here, and this would be -10 because this is counterclockwise. Again, this 1 into Y, this distance is Y, so 1 into Y would form a -Y moment. That would be balanced with equal and opposite +Y. So that would be coming here. It's not so easy, but it's easy, but it's quite complicated. You'll have to give it an ample time to learn this. Okay, finally, before going to calculate, finally, if I have to calculate the translation, I have to calculate the translation in Z direction. So what I have to do, I have to multiply these two tables, the respective elements of these two tables, because this is under original loading, okay, and this is under a unit action in Z direction, okay, unit action in Z direction at point E. So if we multiply this, the values of this table with this, I'll get del Z at point E. So it's very simple. Okay, if you see here, I have got quite a few terms. I have got -x here, and okay, I've got nothing here. Okay, this is under mz, I have -10x. Here under mz I've got nothing. Here I have -80. Here I have got nothing. Okay, again in member BC I have got something under mx heading, and here I've got this. So these two would be multiplying. Again I've got -80 here, I've got nothing here, so nothing would be multiplied here. Here I've got something under mx and mz. Here I've got something under mxz. So these two would be multiplying. So I've done here, I've multiplied the respective values. So finally I've also calculated the magnitude of EI. This is 32,000 given, this is also given. So I've got this value, and this is actually in kip square inches, and I've converted into kip square foot. And finally I've got 9.45 feet. It's a huge amount. It's a huge magnitude of translation. But you should know why it's so much great, because there is already a load here. You can see that there is already a load here at the free end. This is very easy as well, so I'm going to calculate this. So this is done. You have calculated a del Z by multiplying the two tables, as you have been doing in flexibility method. So I'm going to do this. Next, I have to find theta at x in direction E. So for that I have to apply a unit moment in mx at point E. That's why I've applied a unit moment here. So this would be balanced here, equal and opposite. That would join D has to be balanced, so it has been balanced here. It is balanced here. Again, this joint C would be balanced. The moment, in terms of moment, this is, you should know that this is clockwise and this is counterclockwise. I've been telling again and again that these are my directions, and this is from the right hand rule. These are all counterclockwise. This is my x, this is my y, this is my z. Okay, this 1 kip foot is in Counterclockwise I have balanced with clockwise. Again it has to join B is balanced, and finally it has been balanced. So it's very easy. Next I have to calculate the moment table, and you should know that my origin is E here for this section, and this is actually X. So this is acting in counterclockwise, so here it would be balanced with pure torsion in clockwise direction, +1. That's why it's +1 here. In member CD, my origin is D. I have to find all moments here, and you should know one kip foot is acting counterclockwise. It would be balanced with equal and opposite one kip foot, and this is clockwise. That's why it's +1 here. Finally, in BC, I have origin is C, and I have to find all moments here. This is clockwise acting. This is counterclockwise acting, so I have to balance it with clockwise, +1. It's a +1 here. In member AB, my origin is B. I have to find all moments here. This is counterclockwise, so it would be balanced with a clockwise one kip foot, so it is one kip foot here. Okay, to find theta in x direction, rotation in x direction at point T, I have to multiply this whole table, the values in this table, with this FBD under applied loading. So it's very easy. You should know that here it's very easy. I mean, here I've got TX in DE. Here I've got nothing, so it would be 0. Okay, here I've got in member CD, BC, AB have got all the moments under MX. So here it would be 0. However, here it would be multiplying with 1, and it would be multiplying with minus. Again, it would be multiplying it with 1. So respective elements, respective values have to be multiplied, and I've done this. 10z minus z square is multiplied with 1, and then again 600 is multiplied with 1. Okay, so I've got this value. You should know that this is kip square foot. Here it was kip cubic foot. Divided EI, the unit of EI is kip square foot as well, so units would be radians. Okay, now it's your turn, and it's your assignment that you should calculate all other things. I've calculated del z and theta x, so you can calculate del y and del x. You can calculate theta y and theta z, all at e. It's very easy. So it can be your assignment, and by doing so you would be able to learn a lot. I mean, you can ask as many questions as you can, and the concepts are to be grasped or required very diligently. I mean, you should be able to grasp the concepts of moment. You should be well versed with these notations, this right hand rule, why this is counterclockwise, why this is clockwise. You have to learn all this. Thank you very much.